হাই, আমি রুবায়েত খান এবং আজকের লেকচারে দেখব কিভাবে আমরা একটা ম্যাক্সিমাম নাম্বার বের করব from an array or a list using divide and conquer. So let's get started. Let's say we are given a list or an array with these numbers. Now, what is divide and conquer? Divide and conquer is a three-step process where we divide a problem into subproblems and we conquer, which means apply the same function on the subproblems, which is, in short, recursion. And finally, we combine. That is, we combine the output of all the subproblems. Yes, remember, from the base cases or from the base case, and eventually solving the original problem. Okay, now let's see a breakdown how divide and conquer works. So in order to find the max, the first thing we need to do is find the logic, because as we will be using recursion, and recursion is the main technique that is applied in D and C. So we need to find the logic first. The logic to find the maximum using recursion given an array is take the first number. So প্রথম step হচ্ছে take the first number, second, compare it with the max of rest of the numbers. So you take the first number, 5, and you compare it with the max of rest of the numbers. So what is compare? Compare means we check if the first number is greater than the max of the rest of the numbers, then this is the maximum number. Okay, so if the number, let's say if we have 5 here and max of 917 here, so max of 917 is 9. So what we do is you compare. If the first number is greater than the max of the rest of the numbers, then the maximum is this. Otherwise, maximum is this. Okay, this is basically what comparison is. So if the first number is greater than the max, then max is the first number, else the max is the max of the rest. So, and as we are using recursion, we know that if we can find the logic for the first step, the rest of the step will work correctly. Now let's break down how this solution works. So we have this array where we have 4 numbers, and according to our logic, we will take the first number, and that is 5 in this case, and then we compare with the max of the rest of the numbers, and which are 917. You see, our objective was to find the max between 5917 and step 1. Let's say this is step 1. What we are doing is we are taking the first number 5 and we are find them again. We're doing the same thing. Max for rest of the numbers. তার মানে হচ্ছে over here we're breaking the problem. So initially our problem size was n at step 1, or let's at step 1 our problem size has reduced to n minus 1. So this is the divide part. Now we are applying the same function max on the sub-problem, and this is the conquer part. And let's break it down to the base case again. So we do the exact same thing at this step. So we take the first number from this sequence, which is 9, and then we compare it with the max of the rest of the numbers. Again, we take the first number from this sequence, which is 1, and we compare with the max of the rest of the numbers, which is 7 in this case. And our base case is when the problem size is equal to 1, which means when we have only one element over here, we do the actual work, and the actual work is finding the max. So if I have one number, the maximum of this number is itself. So what we do is when we reach the base case, we return this number. So over here, we have 7 because the maximum of 7 is 7. So base case, return the number itself. So over here, 7 gets returned. So this is the combined step. So now I do the work at this step, and I have 1 over here and I have 7 over here. And between these two numbers, 7 is the maximum. So we return 7 to the previous step, and this is combine. Combine basically means we find the real answer at every step, and we return the answer to the previous step. So we return 7 over here. Now I have 9 and 7, so we compare. 9 is greater, so we return 9 over here. Now between 5 and 9, 9 is the largest number, so we return 9, and we have our final result, which is 9. Now what we did, let's go over this again. Our logic was take the first number, compare it with the max of the rest of the numbers, and comparison was if the first number was greater than the max, return the first number, otherwise we return the max, and that is exactly what we did. So we took the first number and we matched or compared it with the max of the rest of the numbers, and max is basically the function, recursive function. So this breaks down until we reach the base case. So the base case is when the problem size is 1, or when we have only one number, that's the maximum number, and we return that number. And at every step, we compare between these two numbers and return which is maximum. And finally, we have the solution to the original problem. Okay, now let's look at the pseudocode of this problem. So we have a function. Let's have a function called max, where we have an array, and we have a pointer. And the pointer is initially 0. So base case is if I is pointing to the last index of the array or list, which means if this is the list, if I is pointing to this one, it means that this is the base case, right? Because I have only one number over here. So we return that number. Else, what we do is we take the first number, or we take the ith number, and we compare it with the max of the rest of the numbers. So we increase the pointer, which means the rest of the number. So if this is the array, I is initially 0. So AI is the ith element, and the rest of the numbers is starts from I plus 1. And as this is recursion, we know that if our logic works for the first step, it will work for all the following steps. So we don't have to worry about the rest of the steps. It will work great. So return the greater between AI and max of AI plus 1. So this is our pseudocode, okay? Now, what is the time complexity? So let's look at the time complexity. So let's take an array where the maximum number is at the end. So I have 1, 9, 17, and 23. And let's take another array where we have the maximum number at the beginning. So let's break down what happens. So when we have an array where the maximum number is at the end, we have the first number over here, and we compare with the max of the rest of the numbers. Then we do the same thing at every step. Okay. And when we have the maximum number at the very beginning, this is what happens. Therefore, we can see that no matter where the maximum number is, the array will be broken down into pieces, smaller pieces, until it reaches the base case. So we can see that no matter where the max is, or no matter what the arrangement of the numbers are, the time taken is same, because in both these cases, the number of steps are equal. So the time complexity of worst case and the best case will be equal. Now, what is the time complexity? So if you see, initially our problem size was n, and at every step our problem size got reduced by 1. So at this step it's n minus 1, over here it's n minus 2, until it reaches 1. Now, if this is our first step, this is step 1, this is step 2, this is step 3, and let's say this is step number k, when our problem size is 1. So can you find any similarity between the step number and the subproblem? So you see the step number exactly matches this constant. So for the kth step, we can say that at step k, the problem size is 1, and we can also write it as n minus k. Okay? So we can say that n minus k equals 1. And from here, we find k in terms of n. So we have n number of steps for solving the problem. So steps number is n. Now the question is, how much time does it take per each line, or to do the comparison? So there are n number of steps from the beginning to the end, and at each step we do some comparison. So how much time does it take to do the comparison? So this comparison is nothing but if and else. So these are constant time operations, which is big of 1. So we can say that at every step there is constant time of operation. So we can say that The total time taken, or the time complexity, is number of steps times the time taken per step, which is 1. So the total time is n, which we can write big O of n. So this is a linear time solution. We already know that this problem can also be solved using iteration, right? Finding the max can be also solved using iteration, which also takes n amount of time for both the best case and the worst case. And using DNC, which is recursion, the time complexity is also same. But which one to choose between, for this particular problem, should I choose iteration or DNC? Of course, we are going to choose iteration because we are not getting any benefit using DNC. Instead, what we are doing is, this is slower, okay? Not in terms of n, but in terms of computation, DNC is slower. Plus, it takes more space back because as we are using recursion, it is using the stack. It's using a stack, okay? So for this kind of problem, for simple problems, which can be easily solved using iteration, we will always choose iteration over DNC. Thank you very much.